Hello, everyone. We'd like to thank Dr. San to join with us today to present a webinar with us. Dr. Carlos San has specialized in transportation engineering for over 32 years, and his research interests include commercial vehicles, safety, law, policy, and work zones. And he is the director of the JOSIM laboratory, involving a network laboratory that includes the following simulators: tracking, driving, walking, bicycling, wheeling, and e-scootering. And he has his BS degree in electrical engineering from UC Irvine, and his MS and PhD in transportation engineering from UCI, and law in JDMU. So I'd like to request Dr. San to start his presentation.
Yes, good morning, everyone. Thank you for the opportunity to speak at the FMRI seminar and to share with you a little bit about my research. So my first question to you, again, obviously we're not in person, so I can't get live feedback, but I want to ask you a question, right? When you think about truck platoons, what do you think about? Right? What do you envision, and how do you envision truck platoons working in work zones? Right? So we have a bunch of trucks all platooned together, and then approaching a work zone, which, as you all know, are uh, uh, atypical, right? Something has changed, right? Because of construction, we've changed the configuration of the roadway a little bit. Maybe lanes are narrowed, maybe there's lane closures, there's cones and barrels and workers around, right? So how do those two mix, right? You have a big old platoon and work zones, right? So that's the topic for today. I'm not going to answer everything related to trucks and truck platooning and work zones, because that's such a big problem that all of us in the transportation community, we're working together to help kind of bring that about in the future. And as again, thank you, Jaisha, for introducing me. I usually don't tell people I'm also an attorney, but we're among friends today, so please don't hold that against me. All right. All right. So again, just kind of as an introduction, right? Should truck platoons talk? And of course, most of the research, when you search for the literature on truck platooning, it's all about the communication among themselves, right? How do we actually get the truck platooning to work, right? Again, let me give a quick definition of truck platooning, autonomous truck platooning, for those of you who aren't as familiar with that. So the hope is to have a lead vehicle being human driven, and then additional trucks can come and platoon and join kind of the platoon and be hands off, right? And just link to the leader, so-called the leader truck. And there's a couple of things, potential advantages that we're hoping will realize. First of all, is of course, with truck platooning, then you have other people not driving, right? So they can relax, but also it's safer because they're now being managed by hopefully good technology that's taking over the following trucks, so that human error is eliminated or potentially eliminated from the driving side. Additional benefits, of course, we're talking about potentially platooning is short headways, meaning that there's drag effects, so there could be energy savings, efficiency gained from the truck platooning. So safety, efficiency are the big two. Of course, there's all sorts of other ramifications that arise from truck platooning, right? So I mentioned that we all the research or a lot of the research has so far been focused on the trucks talking to themselves, the technology needed to actually platoon and link the trucks together and be able to be linked with very short headways, right, to get the drag efficiency. But there's also other questions, right, that hasn't been researched as much, and that is, how about the behavior of surrounding vehicles around the truck platoons, right? How are they going to deal with the fact that now we have a big old long platoon, and not just a big old long platoon, but a big old long platoon potentially driving in a work zone scenario with a bunch of other traffic surrounding it, right? So that's kind of the focus of this talk today. So again, this is kind of a graphic of track platooning, if you ever seen it before, what it looks like potentially. I like the caption here says moving together as one unit, right? So that this is again from Scandia. This is one of the European efforts. All right. So today again, I talked about the introduction. Motivation is to kind of explore not just the fact the communications between the trucks, the technology side, but with people side, right? How do we communicate with drivers that approach this truck? How would that work? What do people think, or how do they behave potentially along truck platoons? And are there anything we can do to make the truck platooning safer for everyone, not just the trucks, but everybody around, and more efficient for everybody uh, traveling in work zones, right? So the method we'll talk about the method that we employ again. Our research is, or for today, the results is from a simulator study, and we'll also discuss the ramifications of that study. So again, but continuing with motivation, work zones, as I mentioned, have elevated risk because of difficult, different driving environment. Oops, I think I saw a comment. Is there an issue? Just make sure. Jaisha, is there an issue with my presentation?
Let me just check.
Yeah, just want to make sure that.
No, we just had one question. So.
Okay, question. Do you want me to address questions? I'm happy to address questions anytime or wait. What do y'all prefer?
So the question is that are any of the truck platooning companies retrieving the WZDX data if available?
Yeah. Um, Thank you for that question. I am actually I did not know the answer to that question at this point. I'm assuming that there's a lot of data being collected because of so we have both the so automation has actually some couple of dual effects, right? When we talk about connected and autonomous vehicles, right? The fact that there's automation means that there's a lot of sensors in play, potentially LiDAR, video, and different systems. And of course, these, because we're platooning, there's a lot of communications. So there's a lot of data being potentially that could be collected, and that will be collected. Part of it for control, part of our for diagnostics, and part of it also for you know post processing in case there is some incidents, both in terms of malfunctioning, but also in terms of actual incidents, where we can reconstruct um, events. Right, y'all. I'm assuming y'all are familiar with naturalistic driving studies that's happening, and we're trying to get better information on this. But to answer your specific question, I did not know what individual manufacturers or platooning companies are doing. I'm assuming that they're collecting because they're in development, right? Usually when we're in development, we're collecting even more data than we would at steady state. Now, but I did not know that in the future what kind of data these companies will collect, and how regulators, public agencies, whether they will actually instill policies for the collection of certain type of data, right? Because that's really good information, and perhaps that's a area that as these develop, that we can all come to a consensus on how to collect, what types of data to collect, the format of data, and have that data augment both our work zone information specifically, but just in general operations and safety. So sorry about the poor answer there, but that's the limit of my knowledge on that question. All right, now continuing with the work zones. Um, so again, things are new, right? So which is it's a challenge, but also it's opportunity, right? So we are helping all of us and all of you at FMRI also in how do we provide some guidance for different folks that are involved with truck platooning to help develop and implement this technology safely and in harmony with all the other traffic that's on the roadway, right? So right now, there's obviously very few regulation guidance. I usually know uh, um, why kind of talk to people about the law. Law is very laggy in the sense that the law does not step in front typically of technology. We kind of wait for issues to develop, controversies before cases actually arrive. So the law usually lags. But of course, we could be proactive, and that is up to kind of our partners in the public agencies to hopefully they will have a vision on how to implement policy and regulations to help promote the safe and efficient operations of truck platoons. Now, we expect truck platooning, again, all of us, of course, in academia, we're technology happy, right? So we want to see technology implement because we see the potential for that to improve society. But of course, there's a lot of challenges, right? It's not an easy question, right? So again, the question that we're addressing today is how does truck platooning impact surrounding vehicles, right? Human-driven vehicles. In how do human drivers react potentially to these truck platoons, right? So we want to and we investigated, right, the potential impacts of truck platoons. We hopefully crafted some suggestions both for the private side for the manufacturers in terms of what kind of communications and that should be provided to drivers, surrounding drivers, but also to policymakers in terms of given that we have gained some results and insights on driver behavior. Should we implement some policies? Should we, for example, provide some education to the general public so that everybody could coexist better and safer around truck platoons? All right. So again, I kind of already explained the uh, kind of truck platoon a little bit. Multiple trucks following a leading human-driven truck. Again, there's various complicated technologies involved. Uh, and a lot of it, of course, automated. And sometimes technology is actually it's becoming more familiar to regular drivers because we are seeing adaptive cruise control, right, in just regular passenger vehicles. So the notion of cooperative adaptive cruise control perhaps is more understandable now to the general population. So again, the benefits is just to review real quickly. Less labor, right? So truck, as y'all know, workforce is another big problem right now, right? So this is a huge problem after the bilateral infrastructure bill has been passed. Uh, there's so much work and not enough labor, right? And but that workforce problem has existed with truck driving like forever, right? It's just like that's like it's like constant shortage of truck drivers as far as I can remember. And so if there's anything can be done to both help, but also even help improve the quality of life at work for these truck drivers, right? That's a good thing potentially. Again, shortening the headways to uh, uh, actually increase capacity, even roadway capacity, uh, reduce fuel usage versus drafting. And of course, the big thing is also with safety. I should have put a bullet point for safety potential. That's awesome. All right. So uh, couple of things that I'm gonna get into then is the methodology. So we'll talk about the simulator studies and some of the instrumentation that we use, and then talk about how we did the study. First of all, why simulator studies, right? Many times people ask me, Dr. Sun, why don't you just do field work? And it's actually a really good question. I don't get offended because, you know, field data is really valuable, right? Because that's the actual kind of in situ, right? That's the environment that we're actually experimenting. But there's some trade-offs, right? Not every study could be done safely, efficiently as a field study. And actually, they're not mutually exclusive, right? Similar studies could be a prelude to potentially field deployment, right? We're just getting data, right? So the fact that a similar study is not perfect doesn't take away from its value of contributing something, right, to our knowledge, right? So first of all, simulator studies, human subjects encountering minimal risks, right? There's just to give you an example, we build a bird scooter, bird or lime, right? One of those e-scooter things, a simulator for the e-scooter, right? So that we can actually test human subject interactions with vehicles, right? Imagine conducting that study in a field study, right? That would not, our institutional review board would not let that fly, right? The fact that you're actually putting people in the path of vehicles, right? So safety is one big reason why we do simulator studies, right? So we're having all these uh, uh, human subjects come in and drive vehicles around the trucks, even though it's in the virtual world, right? So if there happened to be a virtual accident, well, that's not, or virtual crash, that's not a big deal, right? Thankfully, there were actually no virtual crashes in our studies, but if it were to happen, right, everybody's safe. Another advantage of similar studies is it's a highly controlled environment, right? So we can control pretty much every other factor, right? If you go in a field study, right, the sample size has to be large because you're dealing with all these factors, right? You're trying to control factors, right? So your sampling distribution has to be really large. And in the case of similar study, because we control so many factors, right? Every human subject pretty much sees the same scenario, right? We kind of force the human subjects to basically go through the same experiment, right? So you'll find that in the literature, simulator studies tend to have very small sample sizes, right? Partly it's because it's so expensive, right? It takes a lot of time to process the enormous amount of data in very detailed data, right? We have vehicle kinematics data, second by second. We're tracking each vehicle. There's psychophysiological data that we track. So we sacrifice, of course, the sample size, but for very detailed data, right? That's usually kind of one trade-off with simulator studies. Another really good advantage of simulator studies is that it's highly cost effective, right? So multiple options could be tested all at once, right? So when we talk about field studies, then if we're changing factors, right, you will have to, for example, we do a lot of work zone studies, right? And for give you an example, a recent work zone study, we experimented or tested different speed management techniques, right? So we had law enforcement, passive and active law enforcement. We have a speed radar display, right? That flashes if you're going over the speed. Um, and 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 we also had some red and blue lights on contractor vehicles, right? Uh, how we did field studies, we had to do it over multiple weeks, right? So we implement one, one countermeasure, right? Let it collect data, then we'll take that down and then implement another countermeasure and call up the police and say that, oh, start enforcing this work zone from this so and so date, and then we'll remove that. But there's also a lot of challenges with field data because maybe the same population drive through that work zone every day, right? So maybe there's learning bias, right? So what I'm trying to say is that there's no study that's perfect, right? There's challenges with simulator studies, right? You guys can question, well, how realistic, how valid is your simulator study results, right? But the problem is any study has these challenges, right? If you have a field study, there's also validity questions, right? All right. Going back a little bit to our actual experiment setup. So we have the so-called Zoo Sim. Zoo stands for Mizzou, right? Mizzou simulator. So we're using the truck simulator and driving simulator network together for this experiment. As I mentioned before, we have a family of simulators. We have a bicycle simulator, a wheelchair simulator, a walking simulator, e-scooter simulator. So it's kind of fun. You all kind of meet all these modes potentially could meet in a virtual world together. So for this study, we have a truck. It's a Volvo, old Volvo cab that we've fit in our lab to your right here, and then we have a sedan, and that is the passenger vehicle driven by the human subjects. So we call these simulators mid fidelity because these are not the $50 million or $20 million Toyota or the advanced simulators where there's like I don't know bazillion degrees of freedom where there's actually motion, right? It's like you're at Disneyland, right? You're full motion, you're rolling around, right? So we don't have that. We do have a vibration generator, so you do feel like you're when you turn on the engine, it starts vibrating. There's definitely some good resolution and feedback. Obviously, a triple screen. We can actually have up to 6 screens if you wanted to surround the whole vehicle. Um, but uh, um, but uh, but so our fidelity is not as good as the Toyota driving simulator, whatever the $20 million Toyota driving simulator. All right, so this is the scenario that we tested. It's a kind of standard AME-TCD TA, typical application 33, right? Single lane closure, and for our scenario, it was the closure on the right side. And so you have the sign package for as vehicles approach, there's going to be a road closure, lane closure, and as the truck platoon approaches, along with surrounding vehicles, then that there's going to be some weaving, right? Some interaction, and that's what we're concerned about is how are people going to navigate the work zone, and hopefully people will not do anything silly. And how are they going to treat the truck platoon, right? If they are, will certain drivers be tempted to actually to kind of race against the truck platoon? Sometimes you see that happening, approaching work zones, and how are people going to behave in general? All right. So here are the scenarios. Sorry, pardon my. Uh, so we used 10 scenarios. So each individual human subject goes through the same 10 scenarios. We will start with no education, and then follow up with the education scenarios. And those are not randomized because it doesn't make sense, right? Is once this human subject have been educated on truck platoons, the cat's already out of the bag, right? You cannot. I erase the memory, right? I wish we had a Men in Black uh, zapper where I can zap you and say that, hey, forget about what the scenario. So we have to run the education versus no the no education versus education in sequence, but everything else is randomized, right? So to kind of minimize learning bias. We have 2 scenarios in terms of number of trucks. We have 2 truck platoon versus a 4 truck platoon. Again, why we pick those numbers is just some convenient. This is not saying that this is what the manufacturers or the how they will be deployed is that people agree that 2 and 4 are really good numbers. No, it's just a convenient way where it's not an overwhelming number of trucks, right? And we just wanted to test: is there going to be a difference in behavior when you encounter fewer trucks versus more trucks? And we also have 3 different types of signs. Or we have a control scenario where there's no signage in the back of a truck. Then we have 2 digital type of digital signs behind the truck. Well, I'll show you pictures in a moment. One showing the message truck platoon, right? So the drivers will know there's a truck platoon, and then another actually showing the number of trucks that are being platooned, right? So there are different types of messaging going on, right? This is the education that we do. Again, it's not a huge. It's just this paragraph. We just explain to people that a platoon means that the vehicles are traveling together as a group, and they interact with each other. Please do not cut in and interrupt the truck platoon. So it's not just descriptive; it's a little bit prescriptive this education. All right, so as I mentioned, here's what the signs look like. We have the control, right? The no signage, and then we have kind of the different types of digital signs with the message truck platoon, or showing the number of trucks in a truck platoon. All right. Here are a couple of MOEs that we recorded, and we'll definitely you can see those MOEs after the study. So MOE 1, we track if a vehicle actually follows behind truck platoon, or they actually try to bypass or even cut in a truck platoon. We measure the distance between the work zone and the car when it merges, right? So the merging distance kind of gives a sense of efficiency, but also in terms of safety. How early, right? Do they merge last minute, or do they merge ahead of time? Again, that goes to a tangent. We have been involved in studies on early versus late merge in work zones for about 20 years. In the state of Missouri, we're kind of excited about using zipper merge. I do not know, trying to recall Florida, whether you all do zipper merge. I don't think so, but you can correct me if I'm wrong on that. Right. So there's even trade-offs on how we merge, right? So I'm not again, that's a different discussion for a different day, but all I'm saying is that the distance to the merging point actually has some safety and efficiency ramifications. MOE3, the speed of car when it merges, and also MOE4, distance between the car and the back of the last truck and platoon when the car merges, right? So what is the headway between, or separation between the passenger car and the truck platoon? MOE5 is the distance between the car and the head of the leading truck in the platoon when the car merges to bypass. So we have an MOE related to the bypassing and kind of the safety separation between truck platoon and the passing vehicle. We record the braking of the car, also the blinker use by the car. Again, the blinker, we typically consider that as a surrogate of course, the intention to merge, right? So it's kind of a intention of and reveal, because we cannot, right, look into the human driver's brain to see when they intend to do something, but we can, through their actions, right, try to get at people's thought process when they perceive or react to certain events in the simulation. So we've used psychophys instrumentation to try to get better at or understanding, getting more data points on the human driver. Now, I'm sorry to say actually that we ran into some challenges with our study, so I don't want you guys to get too excited. We did try the instrumentation, but I think the overall was that the data wasn't as helpful, right? We had an eye tracking unit on, we had psychophys, we were analyzing their kind of stress level and things like that, but that unfortunately didn't yield very useful data. Right, so the EDA, galvanic skin response. So how much a human subject sweats kind of reveals the stress level, and of course we also had a post simulator survey to actually ask for their direct opinions on the study. So again, a couple of units that we use the Empatica E4 wristband that collects a bunch of data, GSR and blood pressure, volume, and EEG and stuff like that. So again, I don't want to get too excited. Just all I'm saying is that we tried, but sometimes data just doesn't pan out for whatever reason. Sometimes with driving simulator studies, so the Empatica device is actually worn on your wrist, right? And because you're driving, you're moving the steering wheel, the contact is not as good. So I think that's one of the reasons that the data didn't turn out as well, is because we did not maintain contact. Now the alternative is, of course, you have all these caps that you can wear with a lot more sensors that you can actually, or you can wear you can use contact gel and actually mount these detectors on people's bodies. Again, it's going back to trade-offs, right? So you can get greater contact, but it's more invasive or more more difficulty for in terms of being a little more intrusive in instrumenting the human subjects, which again elevates the IRB requirements, and so it's all trade-offs, right? It's really sometimes when you think about human subject studies, uh, uh, for those of you who have actually conducted human subject studies, know that there's a lot of background, a lot of stuff that goes into it that's not usually known. And if you get into it, you know that there's a lot of complexities, right? It's not that easy to take uh, those psychophysics measurements because it impacts the human subject. It affects sometimes the dropout rate. It affects the RB requirements. It affects the comfort level. And then if you have a female and male human subjects, right, you need, I mean, there's different types of comfort level, right? You need multiple research assistants being matched up if it involves more physical contact, right? So there's a lot of issues involved. So again, I'm not. Hopefully, I'm not sounding like I'm making excuses. Like, hey, Dr. Sun, you failed in getting useful data, so you're making a bunch of excuses. I'm just trying to be as honest as I can about the whole process. It's not easy. All right. Now, post-similar survey, of course, it's it's something that should be done, right? It's pretty easy. Just people after they're done with a similar study, we just ask them some key questions. We also typically I administer the SSQ, which is a simulator sickness questionnaire, because with simulator studies, there's always a potential for sickness. All right, so we've talked about the methodology. Let's go ahead and talk a little bit about the results and what we can conclude from the results. All right. Um, Kind of an overall descriptive statistics on following and bypasses, right? So you can look at we kind of cross classify a little bit on compare between the no education and educational scenario. And we notice there's a slight difference, right? On the behavior, right? Especially when it goes to for trucks scenario. Um, but there's still a fair amount of people that bypass even after education. And again, the survey will reveal. We'll get to that question. Why do people, if they know that sometimes that their truck platoon coming, they still choose to bypass. So we'll get back to that question. Circle back a little later. All right. So here's the comparison a little bit about level of education results, right? And so not in terms as much in terms of the bypass result, the binary, whether you bypass or you follow, but in terms of the speed and distance, there was a statistically significant difference, a pretty big difference, as you know. Again, sometimes the p-value, it's statistical significance. Uh, be a little careful because it's a function of the sample size, as I mentioned to you, because similar studies are smaller sample size because of again the overhead with just processing each individual result. That typically similar studies, we're talking about 30 samples. If you have a lot of money, a lot of time, maybe 50 samples, right? Sometimes on certain studies, we're down to 15 samples, right? That's typical sample size for simulator driving simulator studies. So don't take the p-value as, oh, the p-value is 0.074. It doesn't meet the 5% threshold. Typically we don't look at things that way. We look at we show the p-value, right? And obviously we show all the relevant inferential statistics, but we look at everything comprehensively, right? Now, so do note the so I boldfaces. I know I show a lot of tables with a lot of data, right? So I just boldface again some interesting things, and look at again the difference between no education and education in terms of the car speed. There's a significant change, right? 12.9% and 8.58% for between 2 and 4 trucks, and there's also a decrease in the distance for following. So we know that definitely education makes a difference, right? If people are educated, the drivers are educated, then they will behave very differently, meaning that they will actually speed up. Actually, let me go back and just make sure that they understand. Let's see. Actually, I can't. Yeah, right there. All right. I can't go back, but I'll just hit that a little later. The number of trucks also, there's pretty significant difference between 2 and 4 truck scenario. So we know that if the number of trucks being platoon is increased, that also affects how drivers behave. And so kind of sum up a little bit what we're seeing with the education is that when people know or understand that truck platooning is happening, they tend to drive a little more efficiently, right? Keep in mind that the increase in vehicle speed doesn't mean that they're speeding, right? The speeds are still within the work zone speed limits, right? It's not like they are driving really aggressively, but seems so. One possible conclusion is that people actually drive a little more efficiently and know what to do, right? That they don't just see a bunch of trucks and just kind of hang out and kind of are not sure what's going on, right? And they're really careful around the work zone. They kind of have a better sense of, okay, so we have a truck platoon in front of me. I either follow or bypass. And if I follow, I know I'm following a bunch of trucks. I can kind of just follow normally or even speed up and be a little more efficient. So that's kind of the general sense that we're getting out of that data. All right. All right, so number of follows and bypasses by category. So we're kind of breaking down a little bit just to see that what the data looks like. So again, these are obviously not a huge difference, but there is definitely some difference if you don't have a sign versus when you have a sign in terms of how people behave in terms of following and bypassing. Again, later on, we'll get a little bit more insight because we actually asked people, well, why did you bypass? Why did you follow? And it would be kind of telling the survey results, right? Right now, we just get a sense that, hey, the data is showing that there is some difference, both in terms of education, there's effects on even the behavior, potentially with people uh, uh, actually following less post-education. All right, type of signage. Okay, so there's some information about the type of signage. So in general, there is a difference if there's a sign or versus no sign, right? So when people are informed, again, there's kind of has that same kind of element as in education, where people tend to know more what to do, right? Even when there's no sign, if there no education, but there's a sign, there's the aspect where drivers have a little more information. They know there's a truck there, or even sometimes, of course, the type of one type of sign shows the number of trucks, and they behave a little differently. All right. So again, we're showing that there's a difference. Although if you compare the truck platoon sign versus the sign that shows the number of trucks, there's not as great of difference. In other words, the results is not showing the type of sign uh, has effect as much as showing that having a sign or not having a sign has a great impact. And of course, we are restricted, right, by the number of scenarios that we can test. So we didn't, in terms of with signage, right, it's a unlimited, infinite number of combinations, right? You can have different types of wording, different types of size of sign, a color of sign. We've been involved with a lot of experimentation of color and kind of the visible spectrum, how that catches attention and the meaning of different types of sign colors to drivers. So unfortunately, with with the number of scenarios, we have to just pick two things to test, and always test it with a sign that says truck platoon versus a sign that says number of trucks. Survey results, right? So we're seeing that the actual simulator results, and now let's try to actually also make sense of the survey results to see if we can use everything together. Demographics, we try to have a diverse kind of representative sample of the population. The age distribution skew a little bit towards younger participants, and that's just the fact that we can't, we tried to get a representative sample, but sometimes you just take as many volunteers as you can get, right? So we couldn't get, but we did have some older, right? There's 19% of them from between 56 and 70 years old, right? And so we have a different distribution, pretty good balanced distribution gender-wise. And the majority of the participants were unfamiliar with the notion of truck platoons. Couple of stated preference in terms of what people thought about. So people liked the signage. They also like the education. I think in general, they are kind of not overwhelming me, but a significant number of people that felt that that there was a little bit of pressure to platooning. Again, it's it's pretty understandable the fact that you're driving around big trucks, that you're a little more nervous, right? Because these are big trucks. They affect your vision, right? Your situational awareness, because you cannot see beyond them. So it's understandable. And now what's really interesting is the fact, look at that, right? The reaction. So look at the bottom couple of rows when we talk about what do you think, what do you prefer, or what do you believe about driving around trucks? And you see that most people answer, in fact 90% answer that, hey, it's safer just to hang out behind the trucks, to follow the trucks and not try to bypass them. But the truth comes out, right? People are pretty, if you've done human subject studies, sometimes people are pretty honest, and they say that even though I know it's safer to follow, I would actually, a larger percent, 34%, would actually go ahead and bypass, even though I knew it'd be safer not to, right? And you look at the correspondence of that with the simulator study, right? That's uncanny, the fact that the survey results matches right on with the simulator results. In terms of the preference for the type of sign, the fact, I think both types of signage, both the truck platoon and number trucks, work pretty well. But actually, there's a majority that actually prefer having a little more information, and that's understandable. People, I think, want to be informed. And so both sides seems to work. Maybe there's a preference, of course, for more information. So in summary, the post-education, so we already mentioned that the speeds increase again, potentially that indicates again, increase in speed and decrease in headway distances indicate higher efficiency. One could question, well, is there a safety impact with that? Potentially, right? Anytime there's greater speeds, but also safety. When we talk about safety, it's not just about speed; it's also speed differential, right? So the safety question is actually fairly complicated. It's not just the fact that, hey, people are driving safer, driving faster is less safe. There's all sorts of things that we need taking into account, and of course, efficiency is part of that, right? It's a trade-off. We don't just look at safety purely apart from efficiency, right? Because our roadways are high speed. We have high speed access control facilities. And again, we also talked about the fact that 94% of subjects believed it was safer not to bypass, and yes, many people nonetheless chose to bypass. So again, in conclusion, I think we've shown that it's important, public education, that as we kind of deal with these deployment of newer technologies, as we work with manufacturers, and again, all of us as a team, the public agencies, and of course the manufacturers, and the driving public, and of course us as academics, researchers, that we would kind of advise that we do properly educate folks, not about the technology, right? Because there's still uh, human decisions being made in the driving. Uh, Signs are effective in changing behavior, so we would recommend, and perhaps that everybody can work together to standardize signs so that that becomes familiar to drivers. Kind of like the reason why we have the METCD. And there's significant differences in driving when encountering two versus truck, four trucks in a platoon. So then the question arises: how should we regulate? Should there be any regulations in truck platoon as they approach uh, work zones, special work zones, if there's ingress and egress points, uh, and vehicles need to exit, and there's a big old truck platoon, right? Should we request that truck platoons break up? And how soon should they break up? I mean, there's a lot of complicated questions, obviously not pertaining to this study, but things that we need to think about carefully in around the work zone scenario. So we provide some initial guidance um, in terms of we want to provide some suggestions, and of course this there's a lot more details on how best to educate, that the other people hopefully will study also. Again, the truck signage issue, what type of truck signage, the footprint of the truck signage, how big are the letters, and how bright are the displays, etc. Do they distract? Even, sometimes you don't want distraction already. Drivers are already distracted enough, right, with they're looking at their texting and driving, and other driving distraction problems, right? So how do we work all that out together? And then the number of trucks is kind of an interesting issue in truck platooning. So that's all I have for in terms of my presentation. Hopefully there's enough time for some questions.
If anyone have any question, you can ask in the chat box, or you can just unmute yourself and ask Dr. Sam.
Hi, I have a question.
Yeah.
Yes, I'm interested to know, how are you able to collect the volunteers for the simulation? Like what methodology did you use to get the people to do the simulation?
Yeah, thank you for asking that question about how do we recruit participants, right? Human subject study.
Yes.
Uh,
Yes.
One of the things is we bribe them, right? So we do offer incentives. So I think in the past it's interesting because this study was conducted during COVID. That's another thing that I could spend probably a couple of hours talking to you all about, conducting human subject studies in the age of COVID, right? So a funny story, right? We used to for some reason, a lot of people like Chipotle, right? So we used to give like Chipotle gift cards, and we draw a lot of people. And all of a sudden, COVID, people stopped going to restaurants, right? So all of a sudden we have to uh, go back and buy a brand new set of gift cards. We started giving away Amazon gift cards because that's contactless. People can order stuff from the computer, right? So when we talk about human studies, there's even things like that you would think that that not important, but yeah, we need to incentivize properly the amount, and obviously when we're giving money, right, there's a lot of overhead, right? Even the $25 gift cards, we have to need to take information down for every person. We need to report that to the accounting. And the other thing is, we of course uh, use word of mouth is probably the most effective. Of course, we do advertise, right? We can advertise in the downtown Columbia area. We can advertise around buildings, but the most effective is, of course, through word of mouth. Is beg and plead, family, friends, please come join our study, especially the fact that we need a representative sample, right? So you cannot just bank on students, giving students extra credit and saying, hey, show up, because that will bias the
Okay.
age. So you just try your best. Call out friends and family, and hopefully, and also some of the college staff are older, and that's a good sample size, and they're interested, right? They kind of yeah, we know them, they're friends, and they actually are curious about. They always ask me, hey, so Dr. Sung, what do you do research on? And I said, hey, come and see. Come and join us, and get a gift card, and hang out with us a little bit, learn a little more. And that's really not biasing, because they're staff. They're not technical, right? They're not engineers or anything. They're just regular drivers.
Okay.
They just happen to work in the College of Engineering. So,
Mm,
so yeah, good luck is what I say. It's tough. We always worry. But getting 30 is not bad. Getting 50 is a little challenging, but it's not bad. Sometimes we're looking for very specific. So we had a wheelchair study, and that was tough to get wheelchair users, actual wheelchair users, and you really have to really work hard to get that sample. But getting general drivers, licensed drivers, is not too bad.
okay. Thank you so much.
Um, so I have a question. Do you have any suggestion to use track platooning in microsimulation platform like vSim to reduce the congestion in the road?
Yeah, and that's a great question, Janisha. Is the fact that all these tools potentially, there could be a synergism, and we've actually, there's tools out there that where you could actually um, import and export data from one form, from a human kind of a driving simulator to microsimulation, and vice versa, where the microsimulation will actually uh, place or actually control the background vehicles in driving simulators. So that's a really a good issue that you bring up. Um, and of course, these tools are complementary, right? One is focused on macro, right? So when we talk about micro simulation, you're talking about macro in the sense that you're talking about, we're talking about issues dealing with traffic flow and capacity, right? We're not talking about individual driver reactions. So they complement each other quite nicely. So potentially, again, depending on the micro simulation package that you use, some of the information gleaned from driving simulators could be helpful. Although it really depends on, I'm not super familiar with ton micro simulator. We tend to use Vissim for a lot of our experiments here, and there are ways of, even with Vissim, getting uh, the federal highway had a SSI, so you can get actually individual vehicle trajectory information, and do some of the safety studies. But of course, with microsimulation, we're talking about a set of rules. Again, obviously, very very well done, but again, you're talking about a set of rules that govern the car following behavior, and in the case of this, is a cycle. I forgot the exact German name for that. But behavioral model, complicated behavioral model that governs these driving. So again, it's something that we've worked on. I think is kind of new and exciting. Is how do we actually interface all these tools, and complement the micro simulator with the driver simulator, and perhaps Aisha or some of you might work on actually advancing
Mhm.
that area, how to use those in conjunction.
I mean, how they use in vSim?
No, in terms of how do we take advantage of the fact that we have these
Okay.
technology tools, and we can interface them, and kind of maximize the value of each, right? There's a simulator study that we did on for Ameren. So in terms of autonomous ride sharing, where we actually did the driving simulator study, and we also did the VSIM separately. The driver simulator study gave us a sense of driver preferences, driver behavior, and then we used the VSIM to do the capacity analysis. So we look at scenarios of different demand levels, right, and the potential for so they're used differently, but I guess I'm just thinking that they could complement each other, right? So it's how do we best utilize both types of simulation to advance our knowledge.
Okay, thank you so much.
You're welcome.
Thank you so much, Dr. Sun, for presenting with us today. I'll just share the recording and the lecture presentation in our website. So for the audience that we are going to have our next in-person lecture presentation on 24th of February. Dr. Yin from University of Michigan will join us in our campus, and he will present about the transforming network equilibrium analysis paradigm via end-to-end learning.
Well, thank you everybody for putting up with me today.
Okay, thank you so much.
Thank you so much.
You're welcome.
Have a nice day, everyone.
Jaisha and Dr. San, is there a way we could get the slides, something for reference?
I believe
Yes.
already.
I think I'm going to share the slides and also the recording in our FMRI website. So probably today I just upload everything.
Okay. Thank you so much.
Thank you so much.
All right. Have a good day.